I'm Colin.
I'm Jeff.
Desi.
Mark.
And so this is our conclusion video for the flaming flying pool ball experiment. And so to answer the first question, how did it go? Overall, it went well. We had some difficulties both with organization and getting the right data, and then having some difficulties figuring out finding experiments that came out to have very low percent differences. But in the end, we persevered and we got some good data and we had fun and we learned about conservation of momentum.
And as far as roles go, we did a pretty good job of switching it up every day. I think we all did every role that there was. Colin, to keep everything all consolidated, he took all the pictures and videos to have it all in one place, so that was helpful.
Yeah, I think off of that, their teamwork went well. We all worked. We worked well together, and we got things done well. I thought that was good.
Yeah, maybe one thing I thought we had a little more trouble with was when doing the calculations, kind of looking at the measurements, and we had trouble with some conversions at first, but we worked through it. Got it all done. But yeah, just kind of looking at the data and analyzing it and looking at what it should be, what this means, what that means. But it all worked out in the end.
We're going to be explaining how our pool ball lost or gained energy and why this could be using air analysis. Is it going to start?
All right, so we set up our pool ball. We had a stand here with a ring on it, which we attached the pool ball, which was hanging from a pendulum. We attached it to the ring using tape. So at this point, all of the pool ball had entirely potential energy and was waiting for us to burn it to get kinetic energy. So at the beginning, it had potential energy, and Colin can give us some of the numbers of potential energy we had. We had about...
So one experiment had a potential energy of 4.88.
So it was about 4.9 every time when we calculated for potential energy. So then we would burn the tape here, and the pool ball would swing down, and then at this point it would have lost all of its potential energy and gained all of its kinetic energy because it is at the middle of the swing. So right when it has all of its kinetic energy, we had a razor at the bottom of the swing, which would cut the pool ball from the pendulum and launch it across onto the platform where we would measure. So at this point, we would have all of its kinetic energy here, and Colin again can give you some of the...
50-50.
About 50-50. So we had, around 50, almost the same as up here. We would calculate for the kinetic energy at this point and compare the two. And usually they were about the same for most of our experiments. And they were typically around 10%, whether it's over by a few points or under by a few points. But that is showing that the ball would lose potential energy while it gained kinetic energy and throughout the experiment, but the magnitude of energy throughout would stay the same.
Right. So that's how we lost or gained energy within the total energy of the experiment itself. To summarize what Desi said, losing potential energy, gaining kinetic energy. However, our overall energy stayed about the same. For example, the potential energy of one experiment was 4.8 at the top and 4.7, and then the kinetic energy at the very bottom was 4.77, leading to a percent difference of 0.0062, which is very small. I mean, the data was very close. Some sources of error, which can lead because of the law of conservation of momentum, momentum and energy should always be conserved within a system, and so our pool ball lost or gained total energy due to some human errors. So some human errors that could have happened are we had to measure at each step, right there at the very top, and then right there right before I hit the razor. We had to measure the height to calculate the potential energy because you needed to measure how far it was from the ground. However, our measurements weren't always accurate due to human error and the limitations of the human eye and the ruler, as well as the tape burning at the top. While certainly better than just ripping it, it wasn't perfect either, because then one side might burn faster, and then the pool ball would sag, and then it would go towards the side. And then additionally, when it hit the razor, then sometimes instead of cleanly breaking, it would swing a bit before breaking, meaning that would affect the outcome, because that would totally change the result. Instead of the ball cleanly just moving forward,
It would affect the distance
Right.
going across for calculating for the kinetic energy.
And then the last one being the measurements from the mark created by the ball landing on the paper, right? From measuring right directly underneath the razor, that wasn't perfect because it's hard in the first place to get a mark perfectly under the razor. And then measuring from that mark to the dot was also never perfect due to the limitations of the length of the ruler and the human eye.
This is for what we learned. So throughout this lab, it was pretty prevalent how all these different equations intertwined. So even through kinematics, which we learned like the first month of school, those came into play big time for us. We learned the relationships between kinetic and potential energy, and how that plays a role in the law of conservation of energy. But yeah.
Yeah, we also kind of just got to observe how the law of conservation of energy and momentum works, because, as Colin and Desi stated, in a bunch of our experiments, we could kind of see how true this was. And also we learned kind of the role of communication when working with a team. That was a big one, because in the beginning, there were a couple times where we thought that someone else was doing something, and it turns out nobody did it. But once we figured out the communication piece, we all intertwined well. And most important part of it all, we learned how to have fun while doing physics. I mean, real fun experiment. Not often you get to play with a razor and a flaming pool ball all in one day. So thought it worked out well.
We are going to be discussing why or how is what we learned in this experiment about energy useful outside of the classroom or in the world at large. So the rest of the group is going to be discussing certain examples and additionally how it's useful in general.
So energy is useful and important because anything that we do in life involves energy. So it's sort of putting a definition on what we do, like our everyday activities.
Yeah, one specific example that I kind of thought of after this lab was just looking out at Shady Hill and seeing the kids on the swing set. Now we kind of understand the basic physics of how swings work with potential energy at the top versus kinetic energy at the bottom. So I thought that was pretty cool.
Yeah, I think that, like Jeff said, it sums everything up. We understand how energy works in the world, and without that, it would have been difficult to kind of understand things like swings. So, yeah. So now I think we're going to talk about our best and worst moments during the lab experience.
I'd say our worst moment was probably after day one. We were doing some calculations, and we went through all 5 different calculations we were trying to do for almost all of our trials, and we realized that we'd forgotten to convert the centimeter measurements into meters. Pretty rough moment, kind of a rookie move, but we worked through it, and we redid all the calculations and straightened it out.
And while I love to focus on the positive moments, and we had certainly more positive moments than negative moments, I think additionally day one was definitely hard for us because I think one of our worst moments was maybe the second half, because the first half was good. I think that was a good moment figuring out all the equations, but the second half was definitely one of our worst moments because we weren't able to get any experiments done as our tape continued to break, and we had to deal with the faulty tape. And that was a struggle as we weren't able to do any data for that day.
Off of that, we kind of learned from our mistakes, and I think that day 2 went very smoothly. That was probably our best moment. We kind of powered through all of the lab experiments, and I think we got all of ours done on day 2, and it's a very successful day as a group.